Good evening everyone. Today continuation of thermodynamic lesson, that is gives free energy and the net work done by the system If any system temperature and pressure become a constant, we know that del G that is equal to del H minus d del S. Change in Gibbs free energy equal to del S, change in enthalpy minus at constant temperature and change in entropy, that is Gibbs free energy. Del G equal to del H minus d del S, that is equation 1. We know that change in enthalpy del H, change in enthalpy del H equal to del U, plus P del V. Change in enthalpy equal to change in internal energy, and pressure is a constant, and del V. There is equation 2. To compare equation 1 and equation 2. So equation 1, del G equal to del H minus d del S. Okay. Equation 2, change in enthalpy del H equal to del U plus P del V. Okay. Equation 2 substitute equation 1 del H value. So we can written as del G. So del G equal to del U plus P del V minus d del S. Okay, this is equation 3. Okay, according to first law of thermodynamics, change in internal energy del U equal to Q plus W. Change in internal energy, that is equal to Q plus W. Q, the amount of heat absorbed or liberated. Plus work. This is equation 4. To compare equation 3 and equation 4. So equation 4, according to first law of thermodynamics, del equal to Q plus W. So equation 4 substitute equation 3 by using del U value. So del G that is equal to Q. Del U, change in internal energy, that is equal to Q plus W. Value substitute Q plus W plus P del V minus d del S. That is equation 5. So equation 5 we can written as del G that is equal to Q plus W plus P del V minus d del S. Okay. Next one, consider del S. Del S means change in entropy. We know that del S, change in entropy that is equal to the ratio of Q at particular temperature, Q by T. Del S equal to Q by T. So cross multiplication. So d del S that is equal to Q. D del S that is equal to Q. This is equation 5. Equation 5. Let us consider d del s. D del s equal to q. So substitute the value. That is del g, that is equal to q plus w plus p del v minus d del s, that is equal to q. So minus q. So plus q minus q cancel. Del g, that is equal to w plus p del v. We can change the sign. So minus del g, that is equal to minus w minus p del v. Minus del g equal to minus w minus p del v. Minus p del v. Okay. Here del g value become decreases. Del g value become decreases. So del g value become decreases. Negative gives free energy. Yeah, reaction becomes spontaneous. Yeah, reaction becomes spontaneous. Decrease the del value, del g value. Del g value become a decreases. Yeah, reaction should be a spontaneous process. Okay. Next, go to criteria. What are the criteria for a spontaneity condition? First point number 1, del H value negative. Change in enthalpy. Change in enthalpy becomes a negative. Reaction becomes exothermic process. Exothermic process. What are the conditions for spontaneity? Del S, change in enthalpy. So change in enthalpy is a negative. Reaction becomes exothermic. Not only enthalpy and also gives free energy. So del G, that is equal to value is a negative. Reaction become spontaneous. Reaction become spontaneous. Next one, del S, change in entropy. Del S, change in entropy. Del S, that is equal to positive. Del S equal to positive. So del S becomes a positive, reaction becomes spontaneous process. Order to disorder state. Order to disorder state. That is gives free energy and work done by the system. Gives free energy and work done by the system. We can conclude minus del G equal to minus W minus P del V. Let us consider first one, equation 1. Del G equal to del H minus D del S. We can change the sign. Minus del G, that is equal to minus del H plus D del S. Minus del G equal to minus del H plus D del S. Here del G value negative, gives free energy is a negative. Change in enthalpy, del H is a negative, but entropy is a positive. So gives free energy and change in enthalpy is a negative. Entropy become a positive. At all temperature, reaction become spontaneous. Okay. Next one, effect of temperature of spontaneity reaction. Spontaneity and non-spontaneity. Spontaneity means without any external factors. For example, all natural process become a spontaneous process. For example, let us consider that is object A, object B. Object A at high temperature 500 degrees Celsius. Object B 300 degrees Celsius. Corrected. Object A at 500 degrees Celsius, object B at 300 degrees Celsius. When heat flow to high temperature to low temperature without any external factor. High temperature to low temperature without any external factor, in this types of reaction become a spontaneous. Next one. Second one. Object A, object B. Object A become a hot body. Object B become a cold body. What are the possibility condition? A to B, because of hot body to cold body. It's not a cold body to hot body. That is a non-spontaneous process. Non-spontaneous process. Okay. Here, what are the temperature effect of spontaneity process? Like del S, first number one, del S. Next del H. Next del G. Del G equal to del H minus D del S. What are the condition at a low temperature and a high temperature? Okay. Del H, first change in enthalpy, del H. Next change in entropy, del S. Del G equal to del H minus D del S. That is gives free energy. Gives free energy. What are the condition? A process become a spontaneous or not spontaneous? That is first one. Del H and del S. Del H become a positive, del S become a negative. Del H become a positive, del S become a negative. Del G equal to del H minus D del S. Negative at all temperature, reaction become spontaneous. Example, ozone, O3. Ozone. Ozone, so reactor, go to O2, oxygen. So 2 times 3 2s are 6, that is 3. First condition number 1. Second one, del H value is a negative, del S value become negative. 2 conditions. Both are is a negative conditions. Del H and del S. Del H and del S both are is a negative. Both are is a negative. So negative conditions at low temperature and high temperature, the value becomes a negative. That is enthalpy and entropy. Enthalpy and entropy is a negative side. At low temperature, reaction becomes spontaneity. So 2 kinds of effort. First one low temperature, next one high temperature. When a low temperature, reaction becomes spontaneous. At high temperature, it's a non-spontaneous. At high temperature, it's a non-spontaneous. Conditions become non-spontaneous. Example, absorption of gas. Absorption of gas. Okay. Suppose both are positive. Del H and del S. Del H and del S. Both are become a positive. At low temperature, at high temperatures. At low temperature, at high temperature. At low temperature, reaction become non-spontaneous. Non-spontaneous. At high temperature, reaction become spontaneous. Reaction become spontaneous. Example, is a very famous one, melting of solid. Melting of solid. For example, take the ice. Ice. 0 degrees Celsius. Ice become changed into water. Ice become changed into water. Ice become changed into water order to disorder state. Both are becoming a positive. Del H and del S. Positive. At a high temperature, reaction becomes spontaneous without any external factor. Suppose at a low temperature, non-spontaneous. Low temperature at a non-spontaneous. Okay. Next, del H. Del S become positive. Del H become positive. Next, del S. Del S. Del S become a negative. Del H is a positive. Del S becomes a negative at all temperature. At all temperature, reaction become non-spontaneous. Reaction become non-spontaneous. Example, water. Water is reactive to O2 to gives H2O2. Hydrogen peroxide. 2 times 2 2s are 4. Only 2 times 2 2s are 4. 2 oxygen 4. Finally, we are conclude both cases del H and del S both are become positive at all temperature. At all temperature, reaction become spontaneous. Reaction become spontaneous. In case suppose del H and del S value. Del H and del S. Change in enthalpy and change in entropy. So both are negative. Low temperature spontaneous, high temperature non-spontaneous. Examples: adsorption of gas. Adsorption of gas. Next, del H, del S, both are positive. Del H and del S, both are positive. Low temperature non-spontaneous, high temperature become spontaneous. Suppose del H is a positive, del S become a positive, del S is a negative. At all temperature, a reaction become non-spontaneous process. This is temperature depends on the particular system, then absorb or liberator. At low temperature, high temperature. Low temperature or high temperature, a particular reaction, whether it is a spontaneous or non-spontaneous. Okay. Next one. What are the relationship between standard Gibbs free energy, del G naught, and equilibrium constant? Okay, equilibrium constant. What are the relationship between standard Gibbs free energy and equilibrium constant? Suppose Gibbs free energy become decreases. It is impossible, cannot be calculated. Because of equilibrium condition, the rate of forward reaction become equal to rate of reverse reaction. Rate of forward reaction become equal to rate of reverse reaction at a simultaneously. Suppose let us consider A plus B to gives reverse C plus D group. A plus B to gives reverse C plus D. Suppose to calculate Kc, equilibrium constant. Kc equal to the rate of forward reaction, that is equal to rate of reverse reaction. Equilibrium constant is a concentration of product divided by concentration of reactant. So concentration of C and the concentration of D divided by concentration of A and concentration of B. The ratio of concentration of product by concentration of reactant. Okay. That is equilibrium condition. We know that del G, change in Gibbs free energy. So change in Gibbs free energy equal to del G naught plus RT ln Q. Change in Gibbs free energy equal to standard Gibbs free energy, del G naught plus RT ln Q. Q is nothing but concentration of product divided by concentration of reactant. Q is nothing but concentration of product divided by concentration of reactant. So C plus D product, A plus B group, that is reactant. A plus B, that is a reactant. So del G naught, we calculate the del G naught, standard Gibbs free energy. So del G naught. So del G naught, that is equal to minus RT ln K, equilibrium constant. This is equation 1. This is equation 2. To compare equation 1 and 2, so ln Q is a concentration of product divided by concentration of reactant. Del G, change in free energy. Del G naught, standard Gibbs free energy. Standard Gibbs free energy, that is equal to minus RT ln K, equilibrium. Ln K, equilibrium. Ln converted to log into 2.303. So del G naught equal to minus 2.303 RT log of K equilibrium. This is a del G naught. Once again, del G naught, standard Gibbs free energy, that is equal to minus 2.303 RT log of K equilibrium constant. Here R is known as gas constant. T, temperature in Kelvin. K equilibrium. That is K equilibrium. So we can calculate del G naught, standard Gibbs free energy equal to minus 2.303 RT log K equilibrium. Okay, equilibrium. Suppose del G naught that is equal to del G naught standard gives free energy del H minus d del S. Del H naught standard change in enthalpy del S naught standard entropy that is equal to RT ln K equilibrium. RT ln K equilibrium. K equilibrium. Finally, del G naught that is equal to del H minus T del S not equal to RT ln K equilibrium. That is negative. RT ln equilibrium. So standard gives free energy. Del G naught equal to minus 2.303 RT log of K equilibrium. Okay. Next one, third law of thermodynamics. Third law of thermodynamics. So third law of thermodynamics, especially entropy. Entropy means order to disorder state. Order to disorder state. So order to disorder state, when a low temperature, when a entropy become low. First point number 1. Low temperature, entropy low. Low temperature, entropy low. Let me discuss about first number 1, solid to liquid, liquid to gas. Let me consider the 3 states of matters. You know, solid to liquid, liquid to gas. Suppose take the ice. Molecule order state, ice. To attain 0 degrees Celsius, melting of ice. To attain 0 degrees Celsius. So 0 degrees Celsius, ice becomes changed into water. Order to disorder. Molecules are loosely packed. Molecules are loosely packed. To attain 100 degrees Celsius, 100 degrees Celsius, water. To attain 100 degrees Celsius, water becomes changed to water vapor. So disorder state kuda. Molecules are very loosely packed. So it depends upon the temperature. Perfect crystalline. Suppose temperature become decreases. So below 0 degrees Celsius, water becomes changed to ice. That is freezing. Crystalline. So solid, liquid, gas. Entropy become increases when the temperature is high temperature. Most of the solid materials is a less entropy. Most of the solid material less entropy because of molecules are closely packed. Molecules are closely packed. So molecules are closely packed like solid. Liquid, molecules are loosely packed. Molecules are loosely packed. Gas, molecules are very loosely packed. That is randomness. That is entropy. So entropy order to disorder state kuda. What are the statement of third law of thermodynamics? The entropy of perfectly crystalline. The entropy of perfectly crystalline, the material is absolute. The material is absolute. 0 is 0. Once again, the entropy of perfectly crystalline material is absolute. 0 is 0. Suppose temperature become decreases, that is impossible. We can mathematically express temperature at that is 0. S become a 0. Temperature is 0, S become a 0. This is a third law of thermodynamics. Third law of thermodynamics. So what is the statement of thermodynamics? Third law of thermodynamics. The entropy of perfectly crystalline material is absolutely 0 is 0. Suppose water. Water to water vapor, temperature is high at 0 degrees Celsius. Water becomes changed to water vapor. The boiling point of water 0. Boiling point of vapor water is 100 degrees Celsius. The boiling point of water is 100 degrees Celsius. So 100 degrees Celsius, water becomes changed to water vapor. It's a very randomness. Very randomness. Suppose 0 degrees Celsius water. Below 0 degrees Celsius, it's a crystalline. Freezing. Below 0 degrees Celsius, molecules are arrested. that is closely packed, less entropy. This is a third law of thermodynamics. Okay, thank you.